Hi, today's video is just a short one. It's an important one when it comes to photovoltaic and when you need to use air conditioning a lot. Air conditioning is considered to be a heavy user and it can pull quite a lot of energy. So when you want to use air conditioning together with photovoltaic, it's many times the question is there, can a photovoltaic system even support these kind of users? And the answer is short, yes it can, of course. If you have a tight system, then anyway the electricity will either come from your photovoltaic area, and when it's not enough, then it will pull the rest from the grid. But it's even much more important when you have an off-grid system that you do not have this kind of variable power users on your system. You need quite constant energy draw. This would be the perfect situation. There's two types of air conditioning systems here on the market, at least here in Thailand. That is the classic one, which is the cheapest, and then the so-called inverter units. So classic air conditioning systems, they are very simple. When the temperature is too high, they switch on. When the temperature is low, then they switch off, and you have always on, off, on, off, on, off on the air conditioning and compressor. The inverter units, they are regulated by output demand. So when the temperature is getting high, the power would be reduced on the packs, and then but still they would continue running constantly. So let me show you as an example how this looks like, and then I show you the details how and why you should, when you have a solar system, at least take the inverter units, how they could help you to use your own energy the best. So our coffee shop has two split AC units. So this one on this side, this is a 12,000 BTU unit, and that one is a 18,000 BTU unit. So shop can cool down 30,000 BTUs if both units are fully running. 12,000 BTU uses about 900 watts when it's fully running, and the 18,000 BTU, that one would use about 1,200 watts. So both together, if they are running fully output, would actually require 2,100 watts, which is quite a lot. So you know, if you want to run high loads with PV, you would have to size up your PV already substantially. But there is one thing which is helping you a lot, and this is you need to have the units which are called inverter. Right, so this is both of these are inverter units, and the inverter units means that these AC units here can regulate their output per demand. So it's not just full output all the time, and when it's not required, no output. It's just when the temperature is reached which you desire, then the output will be throttled down. And I show you now what this shows on the meter. So here you can see the shop at the moment is pulling 890 watts only, right? It's just those two air conditioners which are on at the moment. So instead of 2,100, we are only pulling about 900. That would be equivalent of just the 12,000 BTU unit here. But both of them are running. This graph is showing you now about the differences between inverter units and classic units. So what you see here is, let's say this pink line here, this is the solar available power, and the other one here, this one is the inverter unit. So you see the inverter unit will constantly stay on, it will just regulate the output per demand. And the classic unit, which is this up and down, so this is, you know, when the upper temperature is reached, it would shut off, and then when the temperature is too warm, it would switch on the compressor, and then it goes up, down, up, down, up, down. So we have times of low demand and times of high demand, right? And if you would this overlay now to the available curve, you can see that sometimes when the classic unit shuts down, we have a lot of excess energy, but then when it's turning on, we actually need to import energy from the grid. While at the same time, with the same output, over time the inverter unit would always stay well within our available power. So this is the very big advantage of those inverter units. On our power monitor we can see it. This is actual readouts from the smart meter. This shop is now on phase number 1. We have a about 5 kilowatt array on this one. It is 11 o'clock in the morning, and we are exporting 1600 watts on that phase still, even we have here 2 air conditioning packs on, which is very nice. If this would be classic units here and both would be turned on, this could be close to no export, and then when they turn off, then this would be maybe even 3000 export, and it would just go up and down like this. But now we have a nice constant available power there. Okay, that was it already for today. I hope you found it interesting. Please, if you have some comments, leave a comment below. Please subscribe, like the video, and I see you at the next one. Thank you.